Dear students, in this module we will learn about mechanism of nucleophilic substitution reaction. After studying this module, you should be able to understand theory behind mechanism of substitution reaction, basics of substitution reaction of octahedral complexes, SN1 type mechanism, SN2 type mechanism and interchange mechanism. You should also be able to understand about reaction intermediates that involve in the course of reaction and then the factors that evidence the possible mechanisms. Pathway of a chemical reaction is far more important than the structure of reactant and product itself. In the initial days of chemistry, even determination of structure of compound was predictive with very small number of available characterization tools. Only through reaction condition and outputs no one can predict about the mechanism of a reaction. So reaction conditions, synthetic outputs, possible side products, possible environmental harms, etc. could not be predicted. Clarity of mechanism of reaction helps to understand electronic structure of reactant and product and even their interactions. A mechanism also helps to predict about the synthetic methodology for new reactions and overall control of the reaction. In this module, we will learn about the mechanism of nucleophilic substitution reaction and factors that evidence this type of mechanism. Now, let's learn about the mechanism of nucleophilic substitution reaction. In a metallic complex, metal ion act as a positive point charge or positive dipole, and the ligand shows character of point negative charge or dipole. By this way, reactions of coordination compounds can be predicted by ionic interaction between the metal and ligand. Substitution reactions are those reactions in which an attacking ligand replaces previously attached ligand or from the substrate. The ligand that departs from the complex is called leaving group, and the group that takes the position of leaving group is called attacking or substituting group. Now let's undergo substitution reaction in octahedral complexes. Substitution reaction involves supplement of one ligand by other. Since ligand can be treated as negative point charge or dipole, they are assumed to have nucleophilic character. Therefore, substitution reaction that results replacement of one ligand by other is called nucleophilic substitution reaction. For example, in this scheme you can see MX6 when reacts with Y is a ligand which is having nucleophilic character because of high electron charge over it. It replaces a leaving group X to form MX5Y and a leaving group X. The attacking ligand can attack on substrate MX6 by several ways to produce MX5Y. Therefore, we can have several mechanisms by which this type of reaction may occur, but we consider four broad mechanisms. These are unimolecular nucleophilic substitution reaction, or we also call it dissociative SN1 mechanism, bimolecular nucleophilic substitution reaction, or we also call the same associative SN2 mechanism. Third one is dissociative interchange reaction, which is represented by term ID, and the fourth one is associative interchange reaction, that is represented by IA. Now let's learn them one by one. So let's come to the SN1 mechanism. This mechanism involves two-step process. The first step includes slow hydrolysis of metal leaving group to produce a 5 coordinated intermediate species which undergo rapid combination with nucleophile in the second step. So complex first undergoes dissociation and loses a ligand to produce a 5 coordinated square pyramidal or trigonal pyramidal intermediate complex. Inclusion of new ligand on it again produce a 6 coordinated species which is the product of the reaction. So in the scheme you can see from MX6 by the slow decomposition X departs from the complex by which we get an intermediate MX5, that is a 5 coordinated system which can have either square pyramidal or trigonal bipyramidal arrangement. This intermediate then attacked by an attacking ligand in a fast step and produce MX5Y complex. The first step in this case is a slow step while second is a fast step. It means the rate of reaction depends on the slow step of the reaction and can be given as rate should be equal to K into concentration of MX6, where K is the rate constant for the forward reaction in step 1. Hence, SN1 mechanism is first order reaction, that is, when we consider its kinetics, we can call it unimolecular. Details of kinetics of this kind of reaction will be dealt in the next module. Now let's come to SN2 mechanism. SN2 mechanism also involves two-step and separation of leaving group and attacking nucleophile both occur simultaneously. In this mechanism, new ligand, that is attacking ligand, first adds to the complex to form a 7 coordinated activated complex or intermediate, which readily undergoes dissociation to form the product MX5Y. So as you can see in the scheme, first MX6, that was the substrate, was attacked by the ligand or attacking ligand to form MX6Y. You can see here leaving group has not broken away from the substrate, but before going the leaving group Y is attacked onto it. And in the next step, because of high crowding, because of high steric repulsion, MX6Y decompose or degrade to form MX5Y as product and leaving group X departs from the system. This is also a two-step process. In this case, reaction rate depends upon the first step, that is upon the concentration of complex as well as the concentration of incoming ligand Y, because this step was the slow step. So rate should be equal to K into concentration of substrate MX6 into concentration of attacking ligand, that is Y. Hence, SN2 mechanism is a second order reaction and is bimolecular. However, when solvent itself acts as nucleophile, for example water, alcohol, etc., then reaction shows first order behavior. Non-polar solvent prefers SN2 mechanism. It has also been observed that high concentration of nucleophile favors SN2 mechanism. All these facts we will learn in the later modules. But in the two extremes of mechanism, why we call it two extremes? In one extreme, leaving group has already been departed and then attacking ligand attacks over the intermediate, 5 coordinated intermediate. So this is one extreme in which leaving group completely departs the substrate and then only attacking ligand attack over it. While we have a second extreme in which attacking ligand first attacks over the substrate and by which a 7 coordinated system forms and on this substrate, when steric crowding is more, leaving group departs away. So in between the two extremes of nucleophilic substitution reaction, that are dissociative or associative nucleophilic substitution, an interchange mechanism exists. So what is this interchange mechanism? Let's learn about that. If ligand first attacks onto substrate and form an ion pair, I am not talking about an activated complex or an intermediate, but I am talking about an ion pair in which attacking ligand act as a separate ion and it is forming only substrate. So it is not forming any bond, but it is coming nearby to the substrate. An ion pair used to form. You cannot say whether Y is completely attached with MX6 or it is not attached. This is a position where Y is nearby with MX6. So if ligand first attacked to the substrate and form ion pair before breaking the leaving group from the metal complex species, then the reaction is called an interchange reaction. If degree of assistance of nucleophile is small and reaction primarily undergo dissociation pathway, then the reaction is called dissociative interchange. While if reaction is more tilted towards association reaction, then the reaction is called associative interchange reaction. You can see this in the scheme. MX6 is attacked by the ligand Y to form X5 MXY, which then forms MX5Y complex. So what do I mean by the term reaction is more tilted towards dissociative mechanism or more tilted towards the associative mechanism? If you are forming an ion pair and ligand Y is although coming closer towards the metal complex, but before its attachment, before its linking, if Y completely depart the system, then the mechanism favors SN1. So in this case, Y is attacked onto the MX6 complex, but before attack of Y, X departs. That ion pair only changes the stereochemistry of the complex and no major change or no other major change they produce. So this is a dissociative interchange mechanism. But before breaking off leaving group, if that ion pair, that attacking ligand is getting attached slowly to the metal complex, then the reaction favors SN2 mechanism and we call it associative interchange reaction. Now we have learned 3 different mechanisms or 4 different mechanisms. In all these mechanisms, in the dissociative nucleophilic substitution reaction, you had seen you had an intermediate which was 5 coordinate intermediate. While in the associative mechanism, you got again an intermediate which was a 7 coordinated intermediate. But in case of interchange reaction, we didn't have any intermediate and we got only the transition state. So let's learn about the stereochemistry of the intermediate. The type of intermediate formed during SN1 and SN2 reactions can be learned like this. In SN1 reaction mechanism, 2 types of intermediate can be formed in a 5 coordinated system. The bond MX dissociate to form a 5 coordinated system, but if X departs system without disturbing any other attached ligand, then the intermediate that will form will take a square pyramidal shape. The MX5, this intermediate will be then attacked by the attacking ligand Y to form MX5Y. But if MX dissociates and the remaining MX5 has tendency to arrange themselves to minimize the electronic repulsion in the system, so they may immediately adjust itself to form bond angles in favor of trigonal bipyramidal intermediate, which is then attacked by Y to produce complex MX5Y. So you can get 2 different type of intermediate in the case of SN1 reaction. Since trigonal bipyramidal needs increment of 2 bonds, whereas no such movement is required during the formation of square pyramidal intermediate. Hence, square pyramidal intermediate is generally formed in SN1 mechanism. However, SN1 reaction proceeds through trigonal bipyramidal intermediate only when if we have a pi bond complex formation is possible. Now let's move towards the intermediate of SN2 reaction. In SN2 reaction, we may also have possibility of 2 different intermediates. Let's first see the reaction. In this reaction, you can see why the attacking ligand attack over an octahedral species MX6 to produce an intermediate. Now ligand adjust themselves to produce a 7 coordinated species. They will preferably form pentagonal bipyramidal geometry. In the second fast step, because of high steric crowding, X departs from the system to produce MX5Y. You can see the same in our scheme. Now we can have another possibility of intermediates in which nucleophile Y attacks through the middle of one of trigonal phase. You can see in the scheme. So nucleophile Y attacks through the middle of one of the trigonal phase of the octahedron, forming a octahedral wedge intermediate, in which both attacking group Y and leaving group X are present in equivalent position as given in the scheme. In the first step, X departs from the system to produce MX5Y. The intermediate here framed or formed is called an octahedral wedge intermediate. Since pentagonal bipyramidal requires movement of 4 ligands to adjust the incoming nucleophile, this increases energy of pentagonal bipyramidal intermediate. While octahedral wedge requires minimum movement of ligand, that's why the ligand-ligand repulsion are less in octahedral wedge than in pentagonal bipyramidal. This indicates that SN2 reaction preferably proceeds with octahedral wedge intermediate. Now we have learnt about the mechanism of nucleophilic substitution reaction. We learnt the 4 type of mechanism. We have learnt about the structure of intermediate, possibility of intermediate. But the question raised here, how we predict about a mechanism? How we can say whether this reaction is in favor of SN1 mechanism or in the favor of SN2 mechanism? So here are the factors that affect the mechanism, and we conclude from these evidence that whether reaction will undergo through SN1 reaction or SN2 reaction, or it will take the midway path, that is for the interchange reaction. So let's learn about different factors that affect the mechanism of nucleophilic substitution reaction. Now first one is the effect of substrate. You can think about, in a chemical reaction, what you see, you have the substrate, you have the nucleophile, you have the leaving group, you have the medium. So these only can affect your reaction. So we have to discuss these one by one. So let's understand first the effect of substrate. You can see, with increase of positive charge on substrate, metal ligand bond strength also increases, because with increase of positive charge, size of metal decreases, and by this effect of nucleus is more on the ligand, and therefore attraction between metal ligand will be more. So the bond distance between metal and ligand will be small, while bond strength have also increased. So with increase of positive charge on the metal complex, metal leaving bond strength also increases, and therefore before breaking of the ligand, attacking group may attack over it. So if you will increase the charge on metal complex in same reaction condition, and all things will be same, then with increase of the positive charge on the substrate, reaction will favor more SN2 mechanism. If the ionic size of the metal is decreased, or you have a small ionic charged metal, then in this case also the distance between metal and ligand will be small, and the strength between metal ligand will be high. So in this case also breaking of metal ligand bond is not easy, and therefore this reaction will also favor the SN2 mechanism, because attacking ligand will come first before breaking of metal ligand bond. Substrate may affect more, but these are the major points where substrate affect over it. Now let's learn about the effect of nucleophile. You can see, if you remember about the nucleophilic substitution reaction, you can see rate of nucleophilic substitution reaction remains unaffected by the presence of nucleophile. What is the rate in the unimolecular nucleophilic substitution? Rate is equal to K into concentration of substrate only. So in this case, rate is getting unaffected by the presence of nucleophile. So in this case, nucleophile doesn't affect the rate of reaction. It means an increase in concentration of nucleophile cannot affect the rate of reaction in unimolecular substitution reaction. But if you increase the concentration of nucleophile, rate of reaction in case of SN2 should increase, because in SN2 rate of reaction is equal to rate constant K into concentration of substrate into concentration of nucleophile. With increase of concentration of nucleophile, rate of reaction should increase in case of SN2 mechanism, while it should not affect SN1 mechanism. So, if you increase the concentration of nucleophile, reaction should favor SN2 mechanism. If you increase the concentration of nucleophile, and by increasing the concentration of nucleophile, rate of reaction is increasing, it means reaction is going through SN2 mechanism. Similarly, with the increase of strength of nucleophile, that is, if it is having higher basicity or higher nucleophilicity, then with increase of strength of nucleophilicity, nucleophile will attack easily onto the metal complex, and therefore it will favor SN2 mechanism. Means by increasing the strength of reaction of nucleophile, if rate of reaction is increasing, means reaction is going through the SN2 mechanism. Now, effect of leaving group. A better leaving group prefers unimolecular substitution reaction, because in this case, before attack of nucleophile, leaving group should depart. It is only possible when the metal ligand bond is not very much stronger, and even the crowding inside the system should be that much more that Y should easily get departed from the system. So, the bond between metal ligand should be weak. So, we can say a better leaving group will help unimolecular substitution reaction, while a weaker leaving group will prefer SN2 mechanism to undergo. Now, the fourth effect we can say is the effect of medium. A polar solvent helps to break leaving group from the substrate and therefore supports SN1 mechanism, because in polar solvent they will frame an ionic sphere. The positive ionic sphere will surround the leaving group, while the negative ionic sphere will surround the other metal ligand species. So, polar solvent will help to break the two, that is leaving group and substrate. Therefore, a polar solvent will help to produce a reaction product through SN1 mechanism. With non-polar solvent, the same reaction will prefer SN2 mechanism, because in this case no such interaction is possible, and even if you do not have any solvent, that also will be preferred by the SN2 reaction, because in this case molecule or attacking ligand do not get any hurdle for the reaction or for attacking onto the metal substrate. Now, let us summarize the whole learning. The reaction of coordination chemistry are nearby with ionic interaction, and therefore mechanism involved in the reaction of coordination complexes are nucleophilic substitution reaction. Substitution reactions in octahedral complexes follow nucleophilic substitution reaction either through SN1 mechanism or through SN2 mechanism. Reaction can also undergo through intermediate behavior, and the reaction we call in that case is interchange reaction. It can either have more effect of dissociative mechanism called interchange dissociative mechanism, while it can be more tilted towards associative nucleophilic substitution reaction. So, and in that case it will be called associative interchange reaction. The reaction intermediate form in SN1 mechanism are of square pyramidal type or of trigonal bipyramidal type. Only the reaction in which the ligands can form pi bond complex, in that case only molecule will try to form trigonal bipyramidal intermediate, while in all other cases, since there is no change in the position of ligand, a square pyramidal intermediate will be preferable. The reaction intermediates in SN2 mechanism is having two different possibilities. They can either form pentagonal bipyramidal arrangement or octahedral wedge arrangement. In both the cases, octahedral wedge arrangement is more preferable, and therefore generally reaction is proceeded through octahedral wedge mechanism. We can have different factors that affect the rate of reaction, or that affect or evidence nucleophilic substitution reaction, and in that case substrate, leaving group, nucleophile and medium of the reaction helps to find out the mechanism of the reaction.